Okay, so a vertical asymptote happens whenever you have a 0 in the denominator that does not cancel. So the line x equals 1 is a vertical asymptote for the function f of x is if f of x approaches infinity or f of x approaches negative infinity as x approaches, that should have an A right there, sorry, A, from either the left or right side. So what that looks like is if you, as you get closer and closer to that line, the number gets bigger and bigger and bigger, or smaller and smaller and smaller, but it never actually touches that line. That is a vertical asymptote. It is caused by zeros in the denominator that do not cancel. And we'll look at some problems here in a second. A hole is also called a removable discontinuity. So you could see either one of those phrases on the test. So if they ask for a removable discontinuity, that is a hole. And the reason it's called a removable discontinuity is because we could remove it just by putting 1 point right there where the hole is at. Something like an asymptote, or we'll see some jumps in equations, those are not removable because it would take more than 1 point to fix the problem there. Holes are caused by zeros in the denominator that do cancel. Okay? So let's look at some examples. So if I look at example 1, I've got x squared plus 5x minus 6 over x squared plus 2x minus 24. So for example 1, first of all, discontinuities only come from the denominator because that's the only place you can get zeros in the denominator. So what you'll do for discontinuities is you will set that denominator equal to 0 and you'll figure out what numbers give you 0 in that denominator. So for this case, what should I do? I need to factor. So I'll have x and x. I could use a positive 6 and a negative 4. So that gives me 0, and then remember to switch your signs. You'll have x equals negative 6 and x equals 4. Those are the numbers, if you plug them in, they give you 0 in the bottom. So these are both discontinuities. So if you plug in negative 6 or you plug in 4, it gives you a 0 in the denominator, which is a discontinuity. But I do need to know whether or not these are holes or vertical asymptotes. Alright, so to tell if it is a hole or a vertical asymptote, you need to factor the numerator to see if anything cancels. Right? The discontinuities never come from the numerator, but they do help us see whether it's a hole or an asymptote. So the numerator, if I factored it, I would have x plus 6 and x minus 1. Does that look right? Okay. So, will one of those factors cancel? The x plus 6 will cancel in numerator and denominator because it's in both places. So, if that factor cancels, then its discontinuity is a hole in the graph, or a removable discontinuity, right? It is a hole in the graph if they cancel. But x minus 4 does not cancel with anything in the numerator. So x minus 4, we have a vertical asymptote. It's fine with me if you put VA for that to show vertical asymptote, but just make sure you know what it stands for because, of course, on the test it's going to say vertical asymptote there. Okay, questions on example 1? For example 2, we're just looking at the denominator to start with. Okay, so if I want to solve x to the third minus 4x for equals 0, I need to factor this. What would I do first? I would take out an x, so x times x squared minus 4 would equal 0. And then you could either factor x squared minus 4 or you could just solve it. So x would equal 0. If I just solve this over here, x squared minus 4 equals 0. That means x squared equals 4. So x equals 2, but what do I need with it? Plus or minus because I took the square root of both sides. And if you want here, instead of doing what I just did, you can factor x squared minus 4, so you could have factored it all the way, made it x times x plus 2 times x minus 2, and then that will keep you from missing the plus or minus sometimes if you prefer to do it that way. So, does anything cancel with the numerator? Are you sure? Okay, this x right here will cancel with this x right here. Okay, so that means that at x equals 0, we have a hole in the graph. But the x squared minus 4, or if you factor it at x plus 2x minus 2, it does not cancel. So these two places, those are vertical asymptotes. So you have a vertical asymptote at x equals 2 and at negative 2. A lot of example 3 is already done for you because they went ahead and factored the denominator, right? So what values would give you zeros in that denominator? Negative 3 and positive 2. Will x plus 3 or x minus 2 cancel with anything in the numerator? No, there's nothing there for it to cancel with, right? So what do we have at both negative 3 and 2? Those are vertical asymptotes. For example 4, that denominator, we factor it, we'll have x and x. We need plus 5 minus 1. So I know that my answers here are going to be x equals negative 5 and x equals positive 1. But I need to know whether those are holes or vertical asymptotes. So I've got to factor the numerator. What have I got to do to factor that numerator? Take out an x first, so x, and it'll be x squared minus 2x plus 1. And then I would want to factor, so let's go over here, x and x. It's going to be minus 1 for both of those. So it might be helpful here. That means my f of x is x times x minus 1 times x minus 1. That's how the numerator factored over x plus 5 times x minus 1. Right. So here, will anything cancel? The x minus 1s, right? That tells me that this x equals 1 is a hole in the graph. And since the x plus 5 did not cancel, this is a vertical asymptote. All right, questions? Okay. A horizontal asymptote. For a horizontal asymptote, so with a vertical asymptote, let me just go to Desmos because it'll be a prettier graph, just to demonstrate here. Oh wait, wrong one. Something like y equals 1 over x plus 1. That gives us a vertical asymptote right there at x equals negative 1, right? I'm putting this blue line right here. We can see as you get closer and closer and closer to negative 1, from the left side, you go down to infinity. As you approach negative 1 from the right side, you go up towards positive infinity. So what's happening here is that line, you know, if I were to move this around and sort of zoom in, like, it looks like that the line actually, they touch here, but if you keep zooming in, they never really do touch there. And you could go on down forever and see they don't actually touch here. So, get back here where I can see what we were looking at. So, that's what happens at a vertical asymptote. This graph, however, also has a horizontal asymptote. So if I put in the line x equals 0, y equals 0, y equals numbers are horizontal lines, which is just the x-axis here. The same thing is happening with our x-axis, right? We get closer and closer and closer and closer to 0, but never actually get there. And like eventually it's going to look like it crosses, but if you zoom in enough, it's not touching yet. And you could keep on going forever. It's getting closer and closer, but it never touches there. So to find our vertical asymptotes, we look at the graph, we see if there's zeros in the denominator that cancel. If they don't cancel, then that's our vertical asymptote. For horizontal asymptote, we're looking at what happens on the ends of the graph. So we're looking at what happens as x gets bigger and bigger and bigger, or smaller and smaller and smaller. That should sound like the limits that we were doing in class on Friday. I think we actually did this Thursday. So a line, y equals a, is a horizontal asymptote if, let's see, that shouldn't have asymptote. If for a function f of x equals f of x, if f of x approaches a as x approaches positive or negative infinity. So to find a horizontal asymptote, you're looking at the limit of the function as x approaches infinity. So whenever we do this, we're going to go back to what we learned last week. So if I want to know the horizontal asymptote for example 5, I would do the limit as x approaches infinity of 9x over x squared minus 7x. And we could divide everything by x squared here and look at that. But we can also use our shortcut. What's our shortcut for this? No eats VC. And so Bobo is bigger on bottom 0. That O right there is your 0, right? Botno is bigger on top, not 1, or doesn't have a horizontal asymptote. And eats VC. Exponents are the same, divide coefficients. So for this case, are my exponents larger on the top or bottom? On the bottom. So my answer here is 0. That means that y equals 0 would be my horizontal asymptote. It's always y equals because that's what you'll have for a horizontal line. And you could also look as the limit approaches negative infinity, but for the ones that you're going to see, it doesn't matter whether it's positive infinity or negative infinity. There is a case where it does matter, but we will not see those until calculus. So you won't see those in here. So example 6, if I do the limit as x approaches infinity of 12x to the third minus 8 over x squared plus 2. Right here, this goes, I've got bigger on the top, so this does not exist. So no horizontal asymptote. Then for example 7, I've got f of x equals x plus 2 times x minus 9 all over x squared minus 9. Is this one bigger on top or bottom, or exponents are the same? Exponents are the same because you need to distribute this out before you decide about exponents, right? So you've really got x squared plus 2x minus 9x minus 18 on the top there over x squared minus 9x. So exponents are same on top and bottom. Our highest exponent here is x squared. Our highest exponent here is x squared. So we divide the coefficients. There are no coefficients with these, which means that we have 1s in front of those x squareds. So 1 over 1, which is just 1. So our horizontal asymptote for this graph would be at y equals positive 1. questions? All right, so I really shouldn't have copied that last thing on the notes, should I? Didn't realize it. So what you're going to have for your assignment is this worksheet, and for the worksheet, you're going to find. Oh, I should tell you about domain. Let me do that. Domain, the whole, vertical asymptote, and horizontal asymptotes for all of these. Yeah, I'll show you domain from one of these problems that we've done. Because domain is very, let me just show you one thing about domain, because this is going to ask for domain. Domain is your possible X values. You should have seen that. We've talked about domain some before in probably your classes since you were in Math 1. But domain's your possible X values. So like if you look at number 1, if you factor that in the bottom, you'll get X and X. You'll get minus 3 plus 2. And if you factor the numerator, you'll get X plus 2, X minus 1. Alright. Your vertical asymptotes are your holes. Your discontinuities, they only come from the denominator. So we know X equals 3 and X equals negative 2. Those are your discontinuities. 3, is it going to be a hole or a vertical asymptote? Vertical asymptote. And how do we know that, Chloe? Okay. The X plus 2's cancel, so that's where the hole is at. The X minus 3 does not cancel, so it's a vertical asymptote. So this is a hole in the graph. All right. So for domain, domain is anything that makes your function undefined, which are those 2 points that we have a vertical asymptote in a hole. That's what gives us a 0 in the denominator. Anything else should be fine, right? But our domain for this problem, the way I would prefer to write it is just to write it like this. X cannot equal 3 and X cannot equal negative 2. That is the way that I usually write domain in this case. Let me show you one other way that it might be written for you, just because I'm afraid that you might see this like on the exam, because it will be multiple choice. We did a little bit of interval notation the other day, very tiny bit of interval notation on one of our review problems, right? So this can be any number except for negative 2 and 3. So if I want to use interval notation, that means any number from negative infinity up to what number? Yes, except for we've got to exclude 2 values, right? So the lowest of those is negative 2. So I would say from negative infinity to negative 2, I can have those values. All right? Those are fine. Notice I use the parentheses, because if you have parentheses, that's like less than or greater than. It does not include negative 2. And if you have brackets, that's like using less than or equal to or greater than or equal to. It includes those numbers. So here, because we're not including negative 2 or 3, we want to use parentheses instead of brackets. And so we would say negative infinity to negative 2. And then you'll see this upside down U sometimes. That right there means and whenever you see it written like that. And then, so the next, I can't have negative 2, but I can have anything bigger than negative 2 up to what's the next number we could go to? 3, right? But I'm using parentheses because those are not included. And then I could have from 3 up to positive infinity. So sometimes it's possible you may see that notation on the exam. They also may just put x cannot equal 3 and x cannot equal -2, which will be a little easier. But. Okay. Not all of these necessarily have holes and vertical asymptotes and a horizontal asymptote. It may not have, it's possible it may not have any of those, but probably it has at least one. So your answer might be none for some of these. So do these tonight for me. Actually, you got about 5 minutes. Go ahead and try to do a problem or two before you go. And then we'll check over these.